Welcome to this webinar. Me and Mats will talk a little bit about test systems and especially production tests.
Yes, and we are both working for Tested Systems. We have long experience in working with production test systems and also R&D test systems. But today we will focus on production tests. We are 15 people in our team, and we work full-time with test system development. So we build systems for our customers and deliver them to their production sites, mainly in Sweden and Poland and the Baltic states. We also have systems around the world in, for example, Canada and the US and Asia. So we build them in Sweden and deliver them to the production site where our customer run their production lines. We are focusing on PCBA tests today, and the PCBAs are produced in SMT lines, surface mount lines. So in a line like we see in this picture, we start in the bottom left with the solder paste printing. Then we have some machines for solder paste inspection and component placement. So the solder paste is the lead that is used to solder the components. It's almost like a glue in this system. And the machine places all the components on the PCBA and check that everything is okay. And after that, we come into the reflow soldering machine where the soldering is done. And in the top right corner of this picture, we see the test equipment. After the PCBA is produced, we need to test it because there's often hundreds or thousands of components on a PCBA. And components can be missing, they can be flipped the wrong way, or they can be wrong component or bad component or false component or just misaligned. So we need to detect all the bad PCBAs. In a normal production line, there might be like 3 to 5% of the PCBAs are bad, and they cannot reach the customer, so we need to find them. And we are going to talk about different advanced test technologies today. For example, AOI, automated optical inspection, X-ray inspection, functional testing, boundary scan, flying probe, and in-circuit testing. As I mentioned, each product needs to be tested. So our customer might produce 10,000 or 100,000 or even millions of PCBAs each year, and they all need to be tested before they leave the factory. If a bad product reach the customer, it's very expensive because then they have to ship it back. The customer needs to ship the product back to the manufacturer and get a replacement unit, and that is very costly, and it's also very expensive. And in some cases, we work with big products that might be around 200 kilos or something like that. And then it's not possible to ship it back most of the times. So you will have to send people to repair the broken unit. So the customer will ensure that they deliver high quality products if they have good testing in their production line. Do you have anything to add? No, not on this one. Let us know also if you have any questions. There is a Q&A where you can write. When we come to production testing, there are several types of production testing we do. Today we focus on PCBA, as I mentioned. In this case that we show on this slide, we have products from our customer Nibe. And then we start testing the PCBA.
And then we can test assemblies of PCBA, which is called modules.
Yeah, and a module consists of several PCBAs and a few cables, and that's a new opportunity for the guys that work with the assembly to introduce new faults. So we know that the PCBAs are working, but when we introduce cables and connect several PCBAs to each other, then we need to test again to make sure there are no new faults introduced in the product. And then the modules are shipped to the end of line or the final assembly, and they build the heat pump. And the heat pump is about 2 meters tall and around 200 kilos. And then we need to make sure that everything is working when it's final assembled. So we call this end of line test. Sometimes we call final inspection or final test. And in this case, we start the heat pump and let it run for around half an hour to make sure it works properly, just as it should work in the customer location.
Here we have the AOI. As you can see, we have listed pros and cons to the right. The good thing with an AOI is that it's mostly attached to the SMT line, which all PCBA going through. So you get very fast
test times.
Yeah,
A very quick test.
short test time.
Short time. So
Yeah.
there is a camera that takes a picture of the PCBA and makes sure that all the components are there, and that it can also see if it's the correct component and that it's turned in the correct way. So this is a good way to detect problems early. In most cases, the customer will produce batches of thousands or tens of thousands of units, and then they collect them in boxes, and then they go to in circuit test or final test. So we want to detect with the optical inspection if the first PCBA or the first 10 PCBAs are good, then we can trust the setup of the machines, and we know that we are not producing tens of thousands of bad products.
Yeah. The bad thing with the AOI is that it depends a lot of which operator is programming it, because in the beginning of this process they need to manually approve faults, and if it's a bad operator who's doing this, the machine will learn wrong and pass bad PCBAs through it.
Yeah, you can get both false positives and false negatives. So good units that are really bad or bad units that should be okay. It's possible to make mistakes using the system.
So we think that the AOI is a good complement to other testing, but just using AOI is not good enough, because yeah, you can miss things here.
And the next testing technique we will talk about is X-ray testing. That is also something that you do in the beginning of a batch. I have never seen customers that test every PCBA with X-ray inspection, but you take some of the first few units and you test them in X-ray to see through the PCBA, and you can find hidden faults or hidden defects.
And you can also trim the process for the BGAs, so the soldering is solid on all points.
Yep. But as we mentioned, this is not something you do on each PCBA. You do it on the first ones, or maybe you do it on every 100 PCBAs or something like that.
Exactly. And because the cons is that it takes a lot of time to do the X-ray, and the X-ray is a standalone machine, which also have a limited surface, so you cannot test how big PCBAs. Big PCBAs is harder to test in this case, because you see a small amount of the PCBA in the X-ray.
X-ray is also good if you find in later tests, like in the functional test or the boundary scan or ICT test, if you find boards that don't pass the test and you have a hard time to find the problem, then you can take it back to the X-ray and find the cause of the problem. There might be, so like Kristoffer mentioned, bad solderings in the BGA. The BGA is a ball grid array, so you might have thousands or hundreds of solders on one single component, and they are hidden under the component so that you cannot find them without X-ray. The other option is to remove the BGA component and replace it with a new one. So X-ray can help here to make sure that you are looking in the correct position of the PCBA for the problem. Functional testing is what we do most. It's a very good testing technique. In a functional tester, we start with powering the product on. We start by supplying power to the PCBA so it can start. Then we check for short circuits and other kinds of dangerous problems. After that, we normally download the application software into the microcontroller of the PCBA. And then we ask the PCBA to perform all the functions it is designed to do. So we ask it to start analog outputs or send communication on a certain bus. And in the other end, we have measurement equipment that makes sure that this function is really working. So this is very good for detecting system level faults, and it's also good for testing the product as the customer application wants it to be used. So we test the real world performance. It's one negative thing about functional testing is that it's often very complex. We have products that require cooling water or different kind of loads or different kind of communication interfaces and such. So it can become very complex, the testing environment. We will get back to that later in this presentation.
Yeah, it's also a lot of time consuming in the manufacturing, which which have a high cost in production, but you also find all real problems within this testing.
The products are becoming so advanced, so the software download can take everything from 1 second to 5 minutes just to download the software into the PCBA. And then after that, we have to do all the functions. And if we require restarts of the products, then it can take also from 0 to 30 seconds just to start the product before we can ask it to perform all the functions that it's designed to do. So it can be time consuming. That's why we do a lot of parallel testing. Parallel testing is quite easy in functional test, but difficult with other testing techniques.
Yeah.
Great.
Here we have the boundary scan. Here is this technique is very good because you do not need to attach needles to do this. You only need to attach the equipment to the G-tag interface. You will reduce it's pretty much a complex way of testing because you will communicate through the CPU to all other digital circuits on the board. Yeah, it's very good for high communication and high speed components.
And basically we connect through the JTAG bus and we ask the components to control all the pins, in and out pins on they have, and then we can let them test each other. So the components tests each other's. So this is good for boards with a lot of digital components on it. And many times you need to combine this with functional testing or some other testing technique, since it's hard to test analog components.
Exactly.
And such.
And the IC have a dependency on support for this type of technique. Not all components can handle it.
Flying probe is also a testing technique that is computer controlled probes that can move around, so you can connect to any place on the test object. You don't need a fixture, you just have those probes. As you see in this picture, we have 4 probes, and you can control them to go in and measure on any spot on the PCBA. So you don't need any fixtures. It's quite quick to start testing using flying probe, and the machine is very expensive, but each product you need to test is quite low cost, since you already have the machine and you don't need the fixtures. It's also possible to have, instead of probes, small fixtures. If you need to connect to many test points at a time, then you can have flying mini fixtures. So you move around small fixtures, so it's like probes, but with several pins on it, or several probes on it. So you can have a large number of probes that you move around to do the testing of your product.
Yeah, and the big benefit is that you can also do this with your prototypes, so very early in the development phase.
The biggest downside is that the flying probe machine is very expensive to buy.
Yeah, and pretty slow testing if you have a high volumes PCBAs.
In circuit test is a machine that you purchase, and then you have custom-made fixtures in it, like a functional tester, and then you can test for short circuits, open circuits, resistance, and such, using a single machine and a quite easy to use programming interface. So you get a very high test coverage and fast testing times. One downside is that you don't test it as the customer intended to be used, like functional testing. You don't test the system level. You test only the components and the opens and the shorts.
Exactly. You power up the board and attach all test points at the same time and do all measurements pretty fast, but you will not detect if for example, if it's an audio product, you will not test that you have a full chain of components that is working as it should. Like if you put the audio input and measure the output, you will not know that the audio block is working all the way through the PCBA, not just that the test point is having 5 voltage or 3 voltage or things like that on a single point. Hello, Victor.
No, but I will check. I can see we have a message in the chat. Okay, no, it was not a message, just a comment. Yeah, we also come. Now we are going to talk about the trends talk about the trends in PCBA testing, and one of the biggest trends we see, that's the miniaturization of the products. The PCBs get smaller and smaller, and they contain more and more components. So they are very small, full of components. So we have to test lots and lots of components and functions on a single PCBA, and it has to become smaller and smaller and then contain more and more functions. Most devices on today are connected to the internet, and they have Bluetooth, and they have Wi-Fi, and they have lots of intelligent circuits on them, so they are very complex, and they are getting smaller and smaller for every year. Yeah. Yeah, I touched this subject before. It's the systems are smart nowadays, so the customer purchases a product and brings it home and connects it, and it has to go online and become an Internet of Things, and that requires lots of complex certificates and such inside the product.
To be able to connect the product to the clouds, to the cloud servers, you need SSL certificate, as Mats mentioned. But it also sometimes you can have several certificates. It can be that other equipment should go through this PCBA or this product and up to the cloud as well, which do not have internet with direct connection. So it needs to go through other PCBAs. So we have more and more PCBAs that need encryptions and certificates, which is more and more common. Also, the customers want to collect data from the end users and to analyze how they are using the products to improve it and make it better. We have more and more complexity every year.
And this also requires the test systems to be online. When we download a certificate into a PCBA, we need to contact our customer server to create and download the certificate from their server, and then we take it and write it down into the PCBA. So if the internet connection in the production site is bad, then the production will have a problem. It might even stop. But this contributes to making the functional tester much more complex than
Exactly.
it was.
And the end user also pays for each certificate that we download to their products. So, for example, in production, if they do retesting or debugging or repair of a unit, we cannot download a new certificate each time they are tested, because then we will have a loss of maybe 20 or 30% of certificates. So we also need to handle this, so we can download same certificate into same product if they retest.
Sometimes also the customer downloads code that requires a license, like an IP cost. So each time we download or each time we test the product, it requires licenses and MAC addresses that you buy and Bluetooth addresses that you buy and lots of such things. So it's very, very complex, and we always have to keep track of the product and need to know if it has been tested before if we retest it, because then we don't want to purchase new certificates and addresses and licenses and such.
And the end user also wants to be able to trace which unit has which license and things like that. So we have systems that the end user that the customer can use.
We see more and more products which require multifunctional testers. For example, functional tests. It can be a product that requires functional test in order to test all the functions or all the system level functions. At the same time as we have lots of digital components, like a processor that needs to speak to a memory, and we need to test them at speed. So we often combined functional test with boundary scan. We also combined functional test with ICT, and very common also is functional test combined with optical inspection. If we have a product with lots of LEDs on them, then we often use a camera to capture the LEDs and make sure they are the right color and that they work, of course, and that their intensity and everything like that. So we see more and more combination tests where we have to use different testing techniques to get a good test coverage. And on this slide is also mention the supply chain integration. Our customer or the companies that produce PCBAs for our customers often wants to connect the test systems to their manufacturing execution system. So we have supply chain integration, and that provides better traceability of components and manufacturing data.
Yeah. It's also often connected to the ERP systems, which can provide better process control for our customers. For example, if we can keep track on the whole line that the PCBA have gone through all the steps, and if it has not gone through all steps that it should, the printing label is not shipped out. So we can keep track on that as well, together with the ERP systems.
We see more and more customized testing solutions where the product requires a lot of equipment in order to be tested in a real world environment. It can be, for example, like in this picture, we test a product that heats the water for electrical trucks. If you have an electrical truck, you don't have a motor that generates hot water, then you need a product or a heater for that water. And in order to do that, we need cooling water. So we have a few metric tons of cooling water that needs to be filtered and controlled and recycled. So the systems become increasingly complex and more advanced. And in this case, we have a plumbing company that helps us with the plumbing for this functional tester. So it's not just electronics anymore. It's a lot of other things that we require in our system.
Exactly. We are simulating the truck in the system.
Or production test. So that's something new where we need to simulate the real world. We see more and more 3D inspection techniques. It can be optical or it can be X-ray or something like that, where we can see things like component height and placement, solder joint volumes, and other three-dimensional aspects of the PCBA. And if we combine this with the functional testing, then we can also see LEDs and other stuff that they work and are correct. More and more robots or often cobots show up in production. A cobot is a robot which is not so strong, so it can injure any humans it works with. And we see them for handling PCBAs in different ways. So you can remove the operator and put a robot to place the PCBA in the tester and take it out and sort it in good or bad batches or buckets. And we also see more and more inline testers where we need to test big volumes of the same kind of product. Then we can put an inline tester which is inside the PCBA line. So all the units, all the products that pass through the production line will pass through the tester. And in many cases where they produce big batches, but of different kinds of PCBAs, then we put the inline tester offline. So they will produce a few thousand units and put them in racks, which are 50 stories high. So you put a rack in the inline tester and you have a handler that loads the products one at a time, or in many cases, it's a panel with, for example, 8 PCBAs on them. So you can put 8 PCBAs on at the same time and put it into the testing machine and get it tested and programmed and everything. And on the other side, you will have a unloader or a dual unloader that can sort bad products from good products as well. When we build our test systems, we rely on our software platforms. we use CATS, that stands for Quality Automated Test System. That's a software platform developed in LabVIEW that we use in all our customer projects when it's production testing. And we have been working with this software for something like 15 years. So we can reduce most of the code. When we get a new project, we can just install this code and start testing straight away. And our effort will be focused on the hardware and the fixture, and also the communication with the product itself. We need to be able to communicate with the product to ask it to perform all the functions that it's designed to do. So that is the main part that is unique in each project.
Exactly. The programming, the communication, and the fixture and station is unique.
Yeah. But and also we have a vast amount of drivers. So we have done most of the things we run into, we have done it before. So it's quite quick and easy for us to get up and running. We also use QRM. Each time we test a product, we put out a test report, and QRM will catch that report and upload it to a server, either at our customer location or in the cloud. We have a good way to store all the results and also analyze and present all the results through a web application. Our customers can just log on with a web browser and follow their production in real time and see the yield and the trends and the statistics that they are interested in. We also have a product called QTM, Quality Test Management. That one is used to configure the test stations. One customer can have like 15 or 20 test stations spread around the world. And when they make a new release for a PCBA, then we need to install that in all those stations. And that is quite a lot of work if we do it manually. So we have a web interface that will upload the changes we make to a server and then push them out to the test systems wherever they are, as long as they are connected to the internet.
Exactly. And you can actually schedule the update for a specific date and time, which is very good. We have seen in the past at our customers that they have several stations in different locations, and they have a mismatch of requirements and software and things like that. So they ship out different softwares within the same product. That's why we actually built the system.
So we deliver all the code for the test station this way. It's the firmware for the products, the test sequences, and the software, test software, and everything. So it will upload or download to the test station and install everything that we need.
Yeah, and you can also see all test stations online and check which software they are running. So you have a real-time monitoring.
And in the cases where we don't do production test, we often do R&D test, research and development test. The difference is that when we do R&D test, we don't test thousands of units very quickly. We test one unit for a long time. So these tests can last for minutes or hours or weeks or even months. And when we do systems like that, we have a platform called QMax, which is used by our customers. So we help them get it set up, and then they can create their own test sequences and run their own R&D tests just as they like.
Exactly. It could be like testing the life cycle of the product. Can be test in different temperatures and things like that.
That was all of our presentation. So we would like to know if there are any questions. I don't get any questions. Yeah, Gabriel, you have a question? Can you write it in the chat? I can see it here. Yes, we did say cobots. Henrik Pettersson Falk is asking if you said cobots. Yes, we said cobots. We have been working with them a few times, so they can be used to load or unload PCBAs from the fixtures if you want to reduce the manual labors. I saw someone raise their hand. If you like, please write in the chat or in the Q&A. Here is a few things in the chat. Just
Is anyone of you seeing the same that we have described today? The trends and the changes that we are facing?
I don't get any more questions now. Okay, thank you for attending this presentation, and please contact us if you have any questions. You can find our email addresses and phone numbers on our website. Thank you.